And the quiz will be one graphing question. There's two on here, but the only thing you're going to do on the quiz is graph. So that's question number 1. So we need to sketch this. All right, so we're going to sketch this guy. All right, so how do we do that? How do we start? We start by plotting our points on the x-axis. So every one of these x's gives us a point. So we have -1, we have 3, and we have -3. Agree? Yep. All right, then we are going to count up how many x's we've got all together. So it looks like we have 2, 3, 4, 5. And that's important because odd versus even behaves differently, right? So 5 is odd, and odd is supposed to start down and end up. That's what odd does. But see that guy right there? That's going to turn it upside down. So we're going to start up here. So it starts up. Now, when it hits this point, you should be looking up at the problem and paying attention to where this point came from. This point came from here, which is squared. What does that mean? That means it's going to bounce right off. Doesn't cross through, it bounces right off. All right, and then of course it connects to the next point. Now, where did that one come from? That one came from here. Well, that's squared also, so that's going to bounce off again and connect to here. All right, where did that one come from? Well, that one isn't squared, so it's just going to keep right on going. And that's what you have to do on the quiz. Okay, we're going to go ahead and do the second problem, but the quiz is just that. It's a half a page, one problem, one sketch. Nothing to do with the 2. The negative turned it upside down. But the 2, no. Okay? Done. Now let's look at the second problem on here. The second one asks you to write the equation. All right, so let's see, what's this going to look like? Comes up from the bottom. Okay. All right, so we're going to write the equation for this. All right, who remembers how we start? We got to start by writing the factors, or the parentheses, right? There are 1, 2, 3 x-intercepts, so there's 3 parentheses. And in those parentheses will be x plus 3, x minus 1, x minus 4. Now, before you go any further, this is the part you really got to be focused so you don't forget. Pay attention to how the curve behaves. At this point, aren't we just going straight through there?
Yeah.
Yep, no problem. Oh, going straight through here?
Yeah.
No problem. Uh-oh, we are bouncing here, which means that factor has to be squared. Now, you get half credit if you make it this far, but if you want full credit, you got to figure out what that coefficient is out in front. Is it a -2? Is it a 5/7? What is it? Well, how do we figure it out? Plug in this random point. Obviously, it was given to you for a reason. You plug it in. So 6 goes into for y. and -1 goes in for x. All the x's. So -1 plus 3, -1 minus 1, -1 minus 4 squared. So that'd be 25. So 2 times 2 times 25, -100. And then we'll divide. So we get 6 over -100. How does that reduce?
3 over -50.
3 over -50. And you put that right here. And that is the answer to the question. So, we're going to have a quiz tomorrow. First thing, it's going to be one graph. We're not reviewing. We're going to do it. Because you're doing exactly what problem number 1 was that we just did. That's what we're doing. Okay? Now we're going back to our notes though, because we got some fun stuff going on.
Oh, yeah, we do.
You'll remember that yesterday we were involved with a problem that we had to factor, but we couldn't. So I'm looking now on page 18 of my notes. I'm on page 18 of my notes. And my job is to draw a picture of this thing. And I know that I need some parentheses to do that. Because the parentheses are what gives me my x-intercepts. How do I know there's 3 parentheses? X cubed, right? Now some of those might be the same, that happens, but I know there's at least, it starts out with 3 parentheses. Now, always try to factor by grouping. And I'm not saying you need to even write it down, but think about that first, because factoring by grouping will always be quicker and easier than anything else. But I can tell, and I hope you can too, this is not going to group. Because while I can take an x squared out of here, there is no way I'm going to get a matching parentheses over here. Would you agree with me? So this is another problem, like yesterday, where I am going to have to guess, do a division, and hopefully get a remainder of 0. Now, I promised you yesterday that I would give you a little hint to narrow down your guessing possibilities. Because I don't know about you, if somebody says, Lisa, start guessing numbers, I'm a little bit intimidated by that because there are an awful lot of numbers to guess, right? So math has a handy dandy little theorem. It's called the possible rational root theorem. And so on your paper, you'll see I have written PRR. Those are the possible rational roots. And so what we're doing is narrowing down the possibilities. Right now, when I say guess, you have infinitely many numbers to guess. Infinitely many. I'm going to narrow it down for you, so I'm going to give you a list of possibilities. Now, are you still going to have to guess? Yes, but you're guessing from the list, not from every number in the world. Okay? Here's how the PRRs work. It's real simple. Your possible rational roots, that's what PRR stands for, possible rational roots, are factors of the constant over factors of the leading coefficient. Now that's some math vocabulary, but I think you know what those words mean. In this polynomial, notice that every term has an x except the last one. That's called the constant term. It never changes. I don't care what x is, that term's going to be -6. It's called the constant. So when I build my PRRs, what are the factors of my constant? 6, 1, 2, and 3. Now, plus or minus, you got to include the positives and the negatives. But there are the factors of your constant. And then what do we mean by leading coefficient? The highest variable, which x cubed, right? And so that number right there is a 1. Your leading coefficient is 1. So basically what I'm telling you is the numbers you can guess from are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. That's it. You're going to find your answers in that pile. Now, you can be mad at me. You can say, Miss Ford, that's 8 numbers. You mean I got to guess? Yeah, you do, but now you're only guessing from 8 instead of infinity. Okay? So, pick a number in that pile. I don't care which one. Pick one. 3. All right, we're going to pick 3. So, 3 goes in our box. Remember how this works? Your guess goes in the box. And then you write down the numbers from the problem. Remember that from yesterday? This is called synthetic division. This is our procedure. Notice that I've copied the negatives into the chart. Make sure you included your negatives. All right, here we go. 3 times 1 is 3. Add. 3 times -3 is -9. Add. Oh my golly. 3 times 2 is, you guys are good. Good job. Good job. So now what does that do for me? It tells me that one of my x-intercepts is at 3. The reason we're so excited is because these canceled out. And when they cancel out, that means the remainder is 0. And when the remainder is 0, it means you have found a factor, which is what we're trying to do. Now, do you remember what this is? X squared minus 3x plus 2. Now keep in mind, you're still searching for factors. I think you can factor this. Minus 2 minus 1, which tells me that the other dots, I guess this one, but the other ones will be at 1 and 2. Those are my other dots. You with me? So now I'm going to connect the dots. This is a cube, right? Yep. So where does it start? Cubes. Kids, BFF, x cubed, right there. Where does it start? Down. So it's going to start down. And just pass through each one, and there you go.
Wait, where did you get the third?
Get what?
factor, x squared minus 3x plus 2, but there's 3 points on
The first dot came from the number I guessed.
Oh,
The number I guessed gives me the first dot.
Yeah.
And then these give me the other two. By the way, you guys are really good guessers, and you guessed a factor right off the bat. What would have happened? What would you have done if this wouldn't have been 0? What if this would have come out to be 5? You try again. You pick another number from your list, and you try again. All right, let's see the next one here. Now, I want to emphasize, it is possible to group this and factor. I can take out an x squared, I can take out a -3. But this doesn't work. I can do it, I can do that math, but what's wrong? The parentheses don't match. If your parentheses don't match, you can't do this, okay? So that's not going to work. So I'm not going to do that. Instead, I'm going to, I have to guess.
Let's guess another.
What are my PRRs? Let's write them out just so we have some practice.
18.
The factors of 18, which is 1, 2, 3, 6, 9, and 18, over factors of 1. Okay, well that's a pretty big list.
Would you say it's smart to choose lower numbers?
I do. Usually, honestly, Tex, usually 1 or -1, 2 or -1, 3 or -3 are gonna work. If none of those work, then usually this number is really big. Like it would be like 150 or something. Because that means that bigger numbers are being multiplied together. And that's only an 18, and remember, you're multiplying 3 things. You're gonna have 3 factors to get 18. They're gonna be pretty small. My first guess, when I'm doing this on my own, my first guess is always 1. And if 1 doesn't work, then I go to -1. I'm not saying you have to do that, that's my personal style. But I would always stick with 1, 2, or 3 at least to start. Once in a while, if that number is like a 10, 5 would be okay to try.
Yeah.
But I'm sure not starting with 18.
Yeah.
So Tex, do you have a thought? What would you like to start with?
I'd say let's go for 3 again.
3 again? All right, so here we go. We're going with 3 again. So 1, 4, -3, -18. Make sure when you write down these numbers that you are including all the negatives. And then remember, this number doesn't have to be a 1. It's been a 1 in our problems, but it could be anything. Whatever it is, you drop it straight down. 3 times 1. Add. 3 times 7, 21. Add. Uh-oh. I don't think that's a good one. Right? 2. All right, let's try 2.
Watch this one.
So 2 times 1 is 2. Add gives me 6. Oh, this looks better. Add gives me 9. Oh, there we go. Good job. Yes. Good job. So what does that mean?
You got the answer right.
Means you have a dot at 2.
You write a smiley face on the test.
makes me happy. Tex is gonna put a heart there. Now, what do I do next?
Circle 1, 6, and 9. You know.
These guys right here are really what? X squared plus 6x plus 9. They're pluses. They're pluses.
You can factor that.
And that factors.
X plus 3 and X plus squared.
Oh, wait, yeah. Now be careful because it's okay to write it that way, but you need to recognize that's x plus 3 squared. And the dot's going to go at -3, but there are graphical implications of that, right? That's going to impact my graph because I had that factor twice.
You gotta
It's going to bounce. So it's coming in from the bottom, it's going to bounce and head up just like that. How did Mrs. Ford know it came in from the bottom?
Oh.
It's an x cubed. Guys, it's an x cubed. What do x cubes do?
Start down.
Start down, end up. That's x cubed right there. That's what they look like. Oh, I hope there's another one. Oh, good, there's one more. Now, this is a situation where having your PRRs is really handy because what are my possible rational roots this time? 1 and 7, now plus or minus. Isn't that it?
Yeah.
So you only have 4 numbers to guess. +1, -1, +7, -7. Are you with me, folks? Everybody see that?
Yeah.
So this is a really, really good thing to have for this problem. All right, so what do you want to try first? Oh, 7. Okay, Sam says 7.
Really? I'm really not.
Who said 3? 3 is not even an option.
Kennedy said
Kennedy. 3 is not an option. Kids, your guesses come from this list right here. So I'm trying 7 at someone's suggestion. Here we go. Oh, you guys are so lucky. It works. It works.
We're blessed.
You are blessed. So 7, 1, 2, 3, 4, 5, 6, 7 worked. Now what happens? These guys right here become my new polynomial. It's actually called the depressed polynomial. This is the original.
Me too.
Our depressed polynomial is this. And tell me about that.
It's
It's x
x minus 1 squared.
minus 1 squared. Very good, Gabriella. So that means I have a dot at 1, but because it's squared, it's going to bounce there.
Start practicing
Dave Brown's day back.
What do you think? Aren't you proud of yourselves? You can graph just about everything now.
Thank you, Miss Boyce.
No, you're amazing.
Oh, thank you. I told you to come.
Now, we need to do a couple of more synthetic division problems here. So everybody's good with this. We're going to practice a little bit more synthetic division, and then we got new stuff to move on to. Everybody's good here?
Yes.
Okay. So there are a couple of things about synthetic division that I want to make sure you remember. So the directions say use synthetic division, and do this division. Okay, I am on problem 5 now, which is on the back of page 18. We good? All right. Now, we know when we do synthetic division that we have to write out all of these numbers in a row. But this one's tricky. Do you notice anything right here?
No X to the.
No x to the third. So when you do synthetic division, you have to put the 0 in. The 0 that represents the missing x cubed.
Is that a division?
That's a division. So when there is a power missing in synthetic division, you have to represent it with a 0. All right, now, we know there's supposed to be a number out here in the box. You need to remember that the number in the box is the dot. Okay? So look at this. Where would the dot go? 2. So what goes in the box? 2. The dot goes in the box. So wherever you would put the dot, if you were graphing, that's the number that goes in the box. So then you draw your line across, and this guy comes straight down. So it's a 2, it doesn't matter what it is, it comes straight down. So now, 2 times 2, and add. 2 times 4, add. 2 times 11, add. 2 times 13, add. Now, your job is not to find a factor, thank goodness, because you don't have one, right? How do I know I haven't found a factor? That's not a 0. Your job was to do the division. So tell me what is left. I know that I have a remainder of 27. That's my remainder.
Is that how we write it?
That's how you write it. And before we go on, let me remind you, you already know that. If I did 12 divided by 7, it goes in once and leaves the remainder of 5. So I would write 1 and 5 sevenths. So whatever my remainder is, I put it over what I'm dividing by, right? When you do 2 in the 3, you say that's 1 and 1/2. 1 over 2. So here, my remainder was 27, and I'm dividing by x minus 2. So it's 27 over x minus 2. Now, what is all of this? 2x to the what? Third. Why is it to the third? 1 less. It's 1 less than I started with. So 2x to the third plus 4x squared plus 11x plus 13 plus the remainder 27 over x minus 2. When we do synthetic division, the quotient, this part right here, is always 1 less in power than the original was. So our originals that we were graphing were all x cubes, so the thing I circled became an x squared, 1 less. This one started out as to the 4th, so this is now x cubed. This is called the quotient, and this is called the remainder. How about the next one? What'd you say? No. You only put them in if they're missing between 2 things. So whatever your highest power is, it's 3x to the third. I have a squared, I have a plane, and I have a number. So I have everything I need, Sam. There's nothing missing in problem B. Would you agree with me?
Yeah.
Okay. What's going to go in the box out here? Watch it. -1. Why is -1 going in the box? Because that's where the dot would be, at -1. Remember to always start with the first number. Drop it straight down. Did you get -18 as your remainder?
I don't know how you did it that fast.
Years of practice, my dear. Someday when you're as old as me, and you're a math teacher, you'll be doing it just like that. You'll be doing it 10 times faster. All right, so what's my answer? Exactly. 3x squared minus 10x plus 19 minus 18 over x plus 1. That is what your final answer is. One more. What goes in the box?
1.
Positive 1. Perfect. Do I have anything missing?
No.
No. So remember, when we say missing, we mean like you went from x to the 4th to x cubed to x. You missed a square. We don't have that. We got every power up here. You say you got -1, Sam?
Yeah.
So what do we write in the answer blank? 2x squared minus 6x minus 5 minus 1 over x minus 1. And if the question were, is x minus 1 a factor of this, you would say no. Because the only way you can be a factor is if this works out to be 0. That's when you're a factor. So Q, when are we a factor? When that guy right there where I'm pointing
0.
is a 0. So, look at the very next question. The question is x minus 1 a factor of this? Well, the long way to do the problem would be to actually factor this out. The short way to do the problem would be to simply divide. Because if you divide and get a remainder of 0, you know you have a factor, right? So here we go. Let's divide. What goes in the box? 1. 1, negative 1, negative 4 fourths. Make sure you're getting all the negatives in the right spot. Remember, you'd put a dot at positive 1. Wherever you put the dot is what goes in the box. Here we go.
It is a factor.
It is a factor because when I divided it in, I got a remainder of 0. And that means you have found a factor.
So what should we write because it's not remainder 0?
It says, so the answer would be yes, it is a factor. And why? Because the remainder came out to be 0. Does that work? Sam, you all right with that? Now, would you do the next one? Be careful. I think you have a power missing. So when you have a power missing, remember you have to put a 0 in its place. Did I make a mistake? So what are you gonna say? No, it's not a factor, and it's not a factor because the remainder is not 0. The remainder is actually negative 15. Now, I've done so many of these problems over my lifetime that I knew the answer to this was going to be no before I even divided. Can anybody tell me how I knew that? Huh?
It was missing a power.
No, you can be missing a power and still be a factor. I'll show you an example of that in a minute. But, text?
That number's too low.
Well, close. What do you mean by that?
Well, I don't think the numbers that you have stacked up to, zero.
Okay, let's just look at the problem here. What would be the PRRs for that problem? What would be the possible rational roots? Factors of 1, right?
Yes.
So wait, if the only possibilities are 1 and negative 1, can negative 2 possibly be a root? No. So you could tell on this one that it wasn't going to work because the only possibilities are 1 and negative 1. So if this had been x plus 1, I'd have had to work it out to see. But when it was x plus 2, I knew it wasn't going to work because these are the only numbers that will work. And 2 isn't in this list. All right? Now, we're going to pause for a moment on that. I need to give you one more problem because there's one more thing you need to think about. What? I heard somebody say something.
That's a lot of zeros.
That's a lot of zeros. Right now, the only way you have of figuring out if something is a factor, is if you divide and get a remainder of 0. And the division is not hard to do, but wow. You'd have a 2, and then you'd have to have a 0 for 98, 97, 96, you'd have a lot of zeros, as Izzy said. You see what she's saying? So that is doable, but oh my goodness, how tedious. So I want you to come back over here to this problem that we just did. And I want you to observe something. What if I took this problem and instead of dividing by -2, what if I plugged in -2? Well, if I plug in -2, this will be 16 minus 12, I'm plugging in -2, minus 18 minus 1. I plugged in -2 for all of the x's. Now let's add these up. Let's see, 16 minus 12 is 4. Minus 18 would be -14. Minus 1 is -15. So in other words, there's another way to get the remainder. Instead of dividing, you can just plug it in. So instead of dividing by 1, I will just plug in 1. So 2 times 1 to the 99th is just 1. Minus 3 times 1 to the 74th is just 1. Plus 2 minus 2. What does all that add up to? 2 minus 3 plus 2 minus 2. -1. Wait a minute. Is it a factor? No. The remainder is -1. The number that you get when you plug in is the remainder. So if we only want to know the remainder, you don't have to divide. Just plug it in. Bye, Gabriella. How come she gets to leave? Is that what you just said? All right. Right now, quickly, I don't want to start this last section here. So right now, quickly, I want you to sketch this. Do it on the desk or find a piece of paper or something. Sketch this guy. This is what your quiz is going to be like tomorrow, first thing. So this is a good indicator. Brendan, you want to sketch this for me? This is a good indicator of whether you're ready for the quiz or not. Izzy, were you on your phone?
Using a calculator.
Using a calculator?
Yeah.
For what?
Sorry, I was going ahead.
You were what?
I was going ahead on the notes.
I'm not even sure what you'd use a calculator for on the ahead on the notes, but let's stay focused on what we're doing. We're sketching this because that's what our quiz tomorrow is going to be. We're down to 3 minutes. We got to get her done. We can. I'm positive. You can do it. We should start with some dots. Where do we start with them? -1, and we're labeling them. +2, we'll count up our X's. So we've got two more, and one more. So that's a total of 5. 5 is odd. Odd is this, but there's a negative in front of it.
So it's the other way around.
So it's the other way. It's going to start up here. Right?
Yeah.
Now, that dot came from this factor. So it goes right through. And connects to the next dot. That came from this,
So it
which has
bounces.
a
It
square. So it's going to bounce off and connect to the next dot.
It's gonna bounce off of it.
Which came from this one, so it's going to bounce off and head on down. That is what your quiz tomorrow is. Okay? All right, please do not stand up unless you're putting away your markers and erasers. Make sure you clean up all your trash.